In this second video about LightWave 11 Bullet Dynamics, we're going to take a look at how the initial activation option may be used to control the dynamic state of an object through time. In this scene, we have several object layers, a ground plane and 8 toroids. Now, let's open the Bullet Dynamics panel. I already have the ground plane object selected. Let's make it a static body. Let's select the toroids and make them rigid bodies, ready to fall on the ground plane. Let's change the collision shape of the ground plane to box. When we play the animation, all is working as expected, with the toroids falling down. Under the Activation tab, we can take a look at the Initial Activation option. This option lets us control exactly when an object will start to be dynamic. It is set to start active by default. That means that as we hit play, the object will start to react to forces and collisions immediately, starting from frame 0. The second option is Start Sleeping. Let's set this option for the currently selected objects. If we play the animation, nothing is happening, since the dynamic object needs to be activated by a collision with any other dynamic body. Now, let's select the toroid on top and change the initial activation back to Start Active. As the mesh collides with the second toroid, this one stops sleeping and starts to fall down, generating some kind of a chain reaction. Let's see how the Activate on Last Key option works. This option lets the user decide at which frame a dynamic object has to become active, depending on where its first keyframe is set on the timeline. At the moment, the object has a keyframe set to frame 0. So we can't see any difference when playing the animation. But if we move the keyframe to, let's say, frame 30, the object will become active at that frame. Now, let's take a look at another very useful dynamic body feature that works really well with the Activate on Last Key option. If we create 2 keyframes for a dynamic object, we can define a movement and rotational vector that will be used as the dynamic calculation starts. Using this method, the user can assign an initial force and direction to any rigid body. We're now throwing the toroid against the other objects. The difference in both space and time between the 2 keyframes defines the strength and the direction of the shot. Of course, we can move the 2 keyframes forward in time and get the action properly delayed. In this case, it will start at frame 20. If we set even all the other toroids to Activate on Last Key and move the first keyframe forward in time, we will discover that the dynamic body using this option, even if still not awake, can act as a collider for other dynamic meshes. Even if LightWave Bullet Dynamics are really fast and precise, having this kind of control is really important, because it allows the artist to define a precise choreography while directing the actors in the scene.